Today we're discussing surface areas of pyramids and cones. This is our content standard and our mathematical practices. Previously you found areas of regular polygons, and now we're going to find lateral areas and surface areas of pyramids. And we're going to find lateral areas and surface areas of cones. We have 4 new vocabulary words: regular pyramid, slant height, right cone, an oblique cone. The lateral faces of a pyramid intersect at a common point called the vertex. 2 lateral faces intersect at a lateral edge. A lateral face and the base intersect at the base edge. The altitude is the segment from the vertex perpendicular to the base. A regular pyramid has a base that is a regular polygon, and the altitude has an endpoint at the center of the base. All the lateral edges are congruent, and all the lateral faces are congruent isosceles triangles. The height of each lateral face is called the slant height, or L, of the pyramid. The lateral area L of a regular pentagonal pyramid is the sum of the areas of all its congruent triangular faces, as shown in the net at right. Key concept is the lateral area of a pyramid. We're given the formula. The lateral area is 1/2 of the perimeter of the base times its slant height. Notice L is representing slant height. So to find the lateral area of a pyramid, you simply substitute your measures in to the formula. So the lateral area of this pyramid is 25 square meters. Okay, time for you to check your progress. So pause the video, then come back and check your answer. The lateral area is 1/2 of 4 times 4 is 16 times the slant height of 8. We get 64 square inches. The surface area of a pyramid is the sum of the lateral area and the area of its base. So there's the sum of its lateral area plus the area of its base. So to find the surface area of the square pyramid to the nearest tenth, first of all we must find its slant height. So we're missing this measure, so we're going to use the Pythagorean theorem. 6 and 4. Square those is equal to the square root of 52. Next, we're going to find the perimeter and the area of the base. Then we have everything we need to substitute into the formula for surface area of the pyramid. So if we find all the pieces parts first, then it's very easy when we go back to substitute in. So the surface area of the pyramid is about 179 4/10 square meters. Okay, so follow those same steps of determining the slant height, the perimeter of the base, and the area of the base, and then substitute it in order to solve this one. So pause the video and then come back and check your answer. Well, for slant height, I got square root of 73. The perimeter of the base is 24. The area of the base is 36 square inches. And when I substitute them in the surface area formula, I get 138 5/10 square inches. Now, finding the surface area of the regular pyramid, we first find the perimeter of the base. So how many sides does it have? 6 times 10.4, so there's the perimeter of the base. Next, we find the length of the apothem. Okay, so to find the measure of the central angle, we've got a hexagon, so we know all of it measures 360 divided by 6. So we get 60 degrees. So the angle that's being formed in the triangle is a 30-degree angle. From the 30-degree angle we're trying to find the adjacent when we have the opposite. So we're looking for the tangent of 30. is 5.2 over A, the apothem. So we multiply both sides by A, divide both sides by tangent of 30, and we get that the apothem is approximately 9. Finding the area, we substitute in the perimeter of the base and the measurement of the apothem. Take half of that and multiply. So the area of the base is approximately 280 and 8/10. Find the surface area of the pyramid. We simply substitute the perimeter of the base, the slant height, and the area of the base. So the surface area of the pyramid is about 748 and 8/10 square centimeters. So let's try this on our own. So pause the video, then come back and check to see how you did. Well, first of all, we find the perimeter of the base. This has 6 sides, so 6 times 6 is 36 inches. To find the length of the apothem, it's got 6 sides, 360 divided by 6. Our central angle is 60 degrees. But to go to the triangle, we find the tangent of 30. And this part of the measurement of the triangle would be 3 inches. So tangent of 30 is equal to 3 over A. So the apothem is 5.2. The area of the base is 1/2 of the perimeter, which is 36, times that 5.2. So the area of the base is 93.5. Then to find the surface area, 1/2 of 36 times 9 plus the 93.5 gives us 255 and 5/10. Recall that a cone has a circular base and a vertex. The axis of a cone is the segment with endpoints at the vertex and the center of the base. If the axis is also the altitude, then the cone is a right cone. If the axis is not the altitude, then the cone is an oblique one. The net for a cone is shown at the right. The circle with radius r is the base of the cone. It has a circumference of 2 pi r and an area of pi r squared. The sector with radius L is the lateral surface of the cone. Its arc measure is 2 pi r. You can use a proportion to find its area. So here's to find the lateral and the surface area of a cone. Let's try this out. A sugar cone has an altitude of 8 inches and a diameter of 2.5 inches. Find the lateral area of this sugar cone. So if the cone has a diameter of 2.5 inches and the radius is half of that, so that'd be 1.25 inches. We're going to use the altitude and the radius to find the slant height with the Pythagorean theorem. So a squared plus 1.25 squared will give us our slant height. We take the square root of both sides, 8 1/10. Now we're going to substitute the slant height and the radius in, multiply it by pi. That gives us approximately 31 8/10 square inches. Okay, let's check our progress. So find the lateral area of the birthday hat. I went ahead and drew a picture myself of the triangle that's being formed by an altitude of 6 inches. And then what will our radius be? So to find the slant height, I did L squared is equal to 6 squared plus 2 squared. 36 plus 4, take the square root of that. I've got the square root of 40 as my slant height. Substitute that into the formula for lateral area. I've got 2 times the square root of 40 times pi gives me 39 7/10 square inches. Now we're finding the surface area of the cone, and we're to round it to the nearest tenth. Did a quick estimate. Now we've got the exact formula. The surface area is pi r, pi times radius times slant height plus the pi times radius squared. The radius is 1 4/10, and the slant height we're given as 3 2/10. Substitute it in and use a calculator to approximate that it's 20 2/10 square meters or centimeters. Let's check our progress. Notice that we're given the radius and the slant height. So pause the video and then come back and check your answer. So the radius is 3, the slant height is 4 5/10, and I substituted into the formula. I get 70.7 This is a concept summary of the formulas for a prism, a cylinder, pyramid, and cone, both lateral area and surface area. So this would be handy to have in your notes. Watch out, the bases of right prisms and right pyramids are not always regular polygons. Okay, when you get this copied in your notes, you're ready to begin the assignment.